Hello viewers, welcome back to my channel. This is Dr. DORCAS NGIGI. We are moving on with our experiments on thin lenses. We have already done 2 experiments where we determined the focal length by observing an object at infinity, and in the next one we looked at the focal length by the method of no parallax. So today we are going to look at the third experiment where we will be using the displacement method to determine the focal length. Okay? Now we are using the same lens, the same converging lens of focal length 5 centimeters. Now in this experiment, we are going first to make a simple projector on what principle? By putting the object between the center of curvature and the principal focus. Remember, when the object is between the center of curvature and the principal focus, the image will always be magnified, true, and therefore unforming behind the center of curvature. So here we are going to use I'm going to use my phone as the object. Now the reason why I've used my phone as the object is because a phone has very good lighting. The lighting of the phone is very good, so you don't need any extra lighting. Okay, and for that reason, I've used my phone for that. So that is my phone. I've placed it there on a cardboard. This just for holding the phone. Nothing spectacular about it. So that is there. So there is my phone. It is held in the cardboard. Okay. Now the other thing I have is my lens. So lens, I've fixed my lens on that part of the cardboard. Now the reason why I've gone for cartons are very cheap and they are readily available, so you don't have to spend so much money when you're making your simple projector. So it's just a box with a lens in front. Now these are just holdings to hold the object. Remember, you want the object to be between the center of curvature and the principal focus. And because of that, I put the marking so that I don't go beyond 10. Remember, my center of curvature is 10 and my focal length is 5. So I don't want to go beyond 10. So I want to play between 5 centimeters and 10 centimeters. Okay? Now I've placed my object inside the carton. You see that? It's a simple thing, just a simple thing. All you need to be careful is this distance. The object distance should be between 5 and 10. Okay? Okay, now I'm going to focus on so I'm going to focus my object, my image on the wall. Okay? I'm going to focus. I'm supposed to get, wait a minute. Trying to focus. Then I'm also going to produce some darkness, because the experiment is much better in the darkness. Just a minute. So there. Okay. So you move the carton forward and backwards to and from until you get a sharp image on the screen. Now what are the characteristics of this image? If you take a good look, you can see that the image is bigger than the object, meaning it is magnified. Remember, our object is between the center of curvature and the principal focus, and therefore the image we expected to get must be bigger than the object, meaning it's magnified. It must form behind the center of curvature, yes. Remember, our focal length is 5, it's very small. So the radius of curvature is around 10. So it means that image is forming behind C, because C is behind C. F is very small in our case. Okay, so that's the image. Now the other thing you note about the image is that it is inverted. And the reason why it is inverted is because it's a true image. Remember, it's a true image. Images that are true form on screens, and they are all inverted. Okay? They are inverted. Now, if you want your image to be upright, then what you need to do is just put your phone upside down. When you put your phone upside down, then the image next time will be upright. I forgot to put my phone upside down, so my image is inverted, and I don't want that. So when you're making your projector, you want to ensure that the images you form on the screen are upright. Okay, now to do that, then you have to put your object upside down. That is your phone. Remember, my phone is my object. And therefore, when you do that, the image you get on the screen is going to be upright. Okay, that will give you even better. Okay, that's how I made my projector. So you can also make your projector in the same way. You don't have to use cartons like me. You can use other containers. You can use, can even use metallic containers. You can decide to use cardboards. You can use wood, anything that can give you just somewhere to hold the phone and to hold the lens. That's all. Okay, and so that is the principle of the projector. So I hope you like what we have done. Now in the second experiment, we are going to do displacement method. So I'm just going to dismantle this. I'm going to remove my phone because I'm still going to use it as my object, and I'm also going to use the same lens in my next in my part 2 experiment. Okay, that is that. In this experiment, I'm going to have that. So I'm going to need my object still. My phone will still be my object. So with my cartoon, I can remove it now. So come closer. I'm also going to remove my lens. So now I'm going to fix the distance S. Remember, in displacement method, we fix the distance. That one does not change. The distance from the screen to the object is constant, it does not change. So what do we expect? We expect 2 images. So I'm going to form the first image that is very small but very clear. Okay. So that's the first image. I hope you can see it. Small but very clear. And it is forming around 6.5 centimeters. Okay, forming around, I'm at 6.5 centimeters. If I move forward, I lose it. If I move beyond that, I lose it. So it is playing around 6.5 centimeters. So that's my first image. Okay. Have you been able to take it? I focused, eh? So now the second image now should be bigger than by my object. So magnify the image. Okay. And where is that image? I must move until I am able to get it. Right now I'm at 20. Move forward. I'm at 17. I think that's where I'm getting the best. 17 centimeters. Okay. Move forward. Now that is small one. Move backwards. Around 17 to 20 there. You have to try and focus. Remember, there is a margin of error in every experiment. So I'm at 17 exactly right now. And you can see on the screen, the image is much better. Okay, so we're going to take that as our second point. So the first point is 6.5, where we get the smallest image, a diminished image. And the other one is at 17. Okay. So we are going to calculate S. We're going to calculate the focal point. The focal length, sorry. Now to calculate the focal length, the formula we said, I taught this in theory, that the focal length, F, remember focal length is small f. I have to rub this. F is S squared minus D squared over 4S. Now remember, S I told you is 25, the distance from the screen to the to my object, the phone. Then D will be equal to what? So I said we were at 17 minus 6.5. Okay, 17 minus 6.5, that is our D. So that gives us what? Let me calculate. So I want to calculate. So we have 17 minus 6.5, that is 10.5. So remember, everything is in centimeter. Now applying that formula, F then focal length will be S squared, that is 25 squared, minus 10.5 squared divided by 4 times 25. So what does that give us? Let's calculate together. 25 squared, that is 625, minus, let's see, 10.5 times another 10.5, that is 110.25, divided by 25 times 4, that is 100. Okay, so 625 subtract 110.25, that is 514.75, divided by 100. So we get the focal length to be divided by 100, take 2 decimal points, 5.1475. So we can take that approximately as 5.12 centimeters by using the displacement method. So remember, the focal length of our lens is 5 centimeters. So considering that there's a margin of error in every experiment, so whatever we have gotten as 5.12 falls within the margin of error. Okay, so we have used the method of displacement to determine the focal length of our converging lens. Number 2, by putting the object between the principal focus and the center of curvature, we have been able to make a simple projector. I thank you for being with me up to the end. I hope you enjoyed the lesson. I'm asking you to kindly share with people you think will require this knowledge, and don't forget to watch my videos. So until the next time, thank you very much and goodbye.